Welcome to Naveen Tech Hub.
So you've probably seen or even built a simple AI chatbot. You know, the kind where the demo goes off without a hitch. It's a great feeling. But what happens when you try to take that simple demo into a real company with all its messy, complicated data and even messier questions? Well, that's a whole other ballgame. Today, we're going way beyond the basics of RAG, Retrieval Augmented Generation, to see what it really takes to build an AI search system that's ready for the big leagues. This is where the fun engineering truly starts. And this quote just hits it right on the head, doesn't it? A simple RIJ setup is fine for basic facts. But what about a real business question? Something like, show me all our enterprise customers in Europe who renewed last quarter and have opened a support ticket about SSO. Whoa. Suddenly, a basic system just falls apart. It needs to connect your sales data, your support tickets, and your customer database all at once. It has to understand time, relationships, and specific jargon. Okay, I know, this looks like a lot. It's way more than a simple ask a question, get an answer loop. This is the blueprint for a system that's built for one thing: trust. But don't worry about the complexity. Think of this diagram as our roadmap. We're going to walk through this entire thing together, piece by piece, and by the end, it's all going to make perfect sense. All right, here's our game plan. We'll kick things off by looking at exactly where and why the simple stuff breaks. Then we'll get our hands dirty building the system's brain with smart data ingestion. From there, we'll dive into something called hybrid search, then learn how to refine those results to be laser focused. And finally, we'll put it all together to get answers you can actually rely on. Let's jump in. First things first, we need a solid foundation. Before your AI can answer anything, it has to understand your data. And I don't mean just pointing it at a folder full of files. I mean building its long-term memory, its digital brain. That all happens right here at the ingestion and indexing stage. So the ingestion pipeline is where the magic begins, and it's a multi-step process. Step 1, process and clean. And trust me, this is a huge job. You've got data coming from everywhere: PDFs, internal wikis, structured databases, even API specs from Swagger. You have to wrangle it all. Step 2, chunking. You can't just feed this system a 100-page report. You have to break it down into meaningful, bite-sized pieces, or chunks. How you do this is actually a really big deal for search quality later on. Then, step 3, we generate embeddings. This is where we use an AI model to turn each chunk of text into a string of numbers, a vector. You can think of it like giving every piece of information its own unique coordinate on a giant map of ideas. And for a truly smart system, the final step, building a knowledge graph. This is where we go beyond just text and start identifying and connecting the dots between companies, people, and products. And that leads us to this, which is really cool. Our system's brain basically needs to know things in two totally different ways. On one hand, you have vector indexing. This is all about semantic meaning, the vibe of the information. It knows that company profits and financial performance are related concepts, even if the words are different. It's great for fuzzy, conceptual questions. But on the other hand, you have graph indexing. This is about cold, hard facts. It knows that company A filed this specific document which mentions this specific risk. To answer complex enterprise questions, you absolutely need both. One isn't better than the other. They're a team. And this visualizes the difference perfectly. That vector space on the left, think of it like a giant cloud of concepts where similar ideas float near each other. It's powerful, but it's a bit abstract. Now look to the right, at the knowledge graph you might build in Neo4j. It's not a cloud, it's a concrete map. You can literally trace the lines connecting a specific company to a document and the risks inside it. You're not guessing at a relationship, you're following a proven path. So how do you actually do this? Well, you've got a ton of great tools. For vector search, you can use open source stuff like Meta's FAISS, or even add pgvector right into your existing Postgres database. Or you can go for managed services like Pinecone or Weaviate. A lot of these use a really smart algorithm called HNSW, which is kind of like a super fast GPS for finding the closest concepts in your data. Then for the graph side of things, tools like Neo4j are the giants in the space. But here's the key takeaway. The pros don't choose one. They use a hybrid approach to get the best of both worlds. Okay, our system's brain is built and loaded with information. Now, a user comes along and asks a question. This is what kicks off the retrieval stage. The system has to sift through millions of data points to find the few golden nuggets that can answer the query. And the way we do that is with a technique called hybrid search. So, what is hybrid search? It's really just what it sounds like. Instead of betting on one search method, we use a team of them. We use vector search to find things that are conceptually similar. We use good old keyword search because sometimes you need to find an exact product ID or an acronym.
And we use graph traversal to uncover connections that the other two would completely miss. We combine the results from all three to get way, way better results. And this diagram shows how that team works together. When a question comes in, the system is smart. It actually creates a plan of attack. It might look at the query and say, this looks like it needs a specific list of customers. I'll write some SQL for our database. Or it might say, this is a fuzzy question about trends. Let's hit the vector database. Or even, this is about who works with whom. That's a job for a cipher query on our graph. It's like an expert that knows exactly which tool to use for which job. So we've used our hybrid search, and now we have a list of potentially relevant documents. But in the enterprise world, potentially relevant just isn't good enough. We need to be sure. So now we move into a super important stage, post-retrieval processing. This is where we take our rough results and polish them until they shine. And this right here is the whole philosophy. It's about quality, not quantity. Our initial search might give us back, say, the top 25 results. But are all 25 actually helpful? Probably not. Some might be repeats, some might be slightly off topic. The whole goal of this next step, which we call re-ranking, is to find the absolute best pieces of evidence in that pile and toss out the rest of the noise. And we've got some powerful techniques to do this. First up, cross-encoders. These are slower but much more powerful models that take a second look at our top results. It's like bringing in an expert to give a final verdict. Then, there's a really clever pattern called LLM as a judge. We literally just ask another AI, hey, looking at this question and this piece of text, does the text actually contain the answer, yes or no? It's amazingly effective. And finally, something that is absolutely non-negotiable in an enterprise setting, filtering. This is where we apply business rules and security like role-based access control, or RBAC, to make 100% sure a user only sees the data they're supposed to. We're in the home stretch now. We have our small, curated set of highly relevant, verified, and secure context. Now, and only now, are we ready to actually generate an answer. But our job still isn't quite done. We also need to constantly measure our system to make sure it's always giving great answers. You see, because of all that hard work we did up front, the final job for the large language model is actually pretty simple and safe. We're not asking it to remember some random fact from its training on the whole internet. That's when hallucinations happen. We're simply giving it a handful of trusted documents and saying, synthesize an answer based only on this. That's the core of advanced RAG. It's how we kill hallucinations and how we can provide citations for everything the AI says. So how do we know if we're doing a good job? We measure everything. We look at a metric called groundedness, which basically asks, is the answer actually supported by the sources, or did the AI just make it up? We measure relevance. Did we answer the user's actual question? Of course, we track latency because speed matters. And then there are classic search metrics like mean reciprocal rank, or MRR. This one just tells you, on average, how close to the top of the search results is the correct document. You want that number to be as close to 1 as possible. So let's take one last look at our roadmap. Hopefully it doesn't seem so intimidating anymore. We've traced the entire path, from a complex question, through smart routing and retrieval, all the way to a refined and generated answer. You can see now that every box and every arrow here isn't just a piece of tech. It's a layer of intelligence, a layer of reliability, and a layer of trust. And that really brings us to the most important question you can ask about any AI system you build or use. Is it just a parrot, cleverly repeating patterns it's seen before? Or, because of an architecture like this, is it truly beginning to understand the structure of your data, the relationships in your business, and what you're really trying to ask? That's the difference between a toy and a tool. So, if you take one thing away from this, let it be this. Building a serious AI search system for an enterprise isn't about one magic trick. It's about smart engineering. It's about a multi-stage pipeline that handles data carefully, uses a hybrid of search techniques, is obsessed with accuracy, and is constantly being measured. And that's all we have time for in this deep dive. I really hope this gives you a clearer picture of how these incredibly powerful systems are actually put together. If this was helpful, do me a huge favor and hit that like button, and be sure to subscribe to Naveen Tech Hub so you don't miss our next explainer. And I really want to hear from you. Drop a comment below and let me know what complex tech topic you want me to tackle next. Thanks so much.